we have Randy Parkman here to give us a demonstration on making pizza from scratch and give a talk on hunting malware beacons. And it appears that in defiance of all the demo gods, he's going to do this live.
Absolutely. Thank you, Moomin. And good evening to everybody. I have enjoyed this PancakesCon so much. There have been so many great videos, and it's so hard that it's 2 tracks. I'm going to have to go back and watch a lot of these on the replay, so I'm so glad that they're recorded. My name is Randy Pargman. I work at Binary Defense in threat hunting and counterintelligence. I've done that for about a year and a half. And before that, I worked at the FBI for 15 years doing cybercrime investigations with a great team of people. So if you have any questions about threat hunting in general, or digital forensics, incident response, or how to work with law enforcement, I'd love to talk to you about that. That's one of the passions that I hold very dear. But another passion is making pizza. So I wanted to do something that would be kind of fun and also a little bit different. And I put a poll out on Twitter yesterday and asked if we should, kind of play it safe and do some PowerPoint slides, or do everything live, including doing live things on Azure Sentinel while we're baking a pizza. And, the votes for live definitely were overwhelming. So that's the way that we're going to do it. I want to give you a little bit of my background just so that you know, kind of where I've come from, and hopefully this will be encouraging to people who are getting started out as well. When I was very young, I got my start in programming with my grandmother. I have a super cool grandma who taught me Atari 2600 basic programming from magazines that came with the basic code, and we type them in one line at a time and see how it works. I'm also very fortunate to have had a mom who homeschooled me, and got to learn by doing and sometimes mess up our family computer. But I think you learn so much more from making mistakes and then fixing them than anything else. So that's how I want to approach this presentation as well. I'm going to show you live as we're kind of figuring out how to do these threat hunting queries. I'm going to assume you know nothing about Sysmon or Sentinel and just sort of introduce those. And the other thing that we're going to do to just make it a little bit more interesting, I have here a pizza that I've assembled. And as I'm starting the threat hunting part, I'm going to put this pizza into the oven behind me. And then what I'd like you to do on the Track 2 chat is let us know when you think the pizza is ready, when we should check on the pizza. I'm going to kind of be watching it here over my shoulder and hopefully not smell it burning. And Moon, if you don't mind, let me know if people are saying it's pizza time. When the pizza comes out, that's my cue. We're going to switch topics and go from threat hunting to how do you actually make pizza. Hopefully ending soon enough that we can take a lot of questions, but if not, I'll go back to threat hunting because there's a lot to talk about there. So let's get this started.
I have to say, this is the most guts I've seen from any presenter to not only have a live pizza demo, but to have the audience dictate its pace. This will be fantastic.
There we go. And all right, hopefully you can see that baking. And now I'm going to share my screen. And, because it's always fun to just share the whole desktop, that's what we're going to do too. Tempting all of the demo gods. All right, so there's the poll. Definitely almost 80% said live. That's why we're doing it this way. So let me introduce first Sysmon and Sentinel. If you don't know anything about it, Sysmon records all of the things that are interesting happening on a Windows machine. And soon there will be a Linux version as well. Sysmon is free software from Microsoft. It's not supported, which means if it blue screens your computer, don't blame Microsoft. It also takes a little bit of work to do some config, but there are some really great websites like Olaf Hartong's modular Sysmon config that will help you get started. But suffice it to say that Sysmon is like the black box flight recorder on an airplane. It records all the things that you might need to go back and investigate if something goes wrong. So that's what we're going to use. Azure Sentinel is not free. It's also from Microsoft. But something that a lot of people don't know is that it's very inexpensive for a home lab. So if you're watching the earlier talk about putting together your own home lab, Sentinel is a great affordable way to go. You can put a lot of logs in, and like with a small home lab, I'm paying less than $5 a month for all the log processing. And then if you're not sending logs to it, you don't pay anything at all, even though you can still query your logs. So let's get started and just see kind of what we have. So I'm just going to type in sysmon, and I have a custom function here. It'll prompt me for a where clause to filter this, but let's just start with looking for all of the sysmon logs in the last 24 hours and see what comes up. This is a great way to get started if you don't know what logs you have available. You can also go over here and see there's a lot of custom logs that I've got put in here. I'm going to collapse this just so we've got some more screen real estate. You can see there's a whole bunch of things like process create. This is obviously something that is important that happens on a computer when a program starts up. And then there's process terminated events. Event ID 2 is file time creation changed. But let's summarize this really quickly just so that we can see what sort of data we've got. The summarize operator is really important in KQL because it goes from having, we've got over 30,000 results here, it's capped our results, to just looking at the things that we want to look at all summed up. So let's do summarize count. So we'll get the number of events by event ID and also rendered description. Because if you don't know what all the event IDs mean, it's kind of nice to see what they're described as. So then let's just click here to sort it by the count and see which things are the most popular. And we can see that registry object added or deleted, registry activity happens an awful lot. Image loaded is like a DLL, registry value set is also very popular. And then network connection detected. This is what we're going to focus on. We want to look at every single time there's been a network connection. Now, I told you this is a small lab. There's just a handful of computers in it, and it's the weekend, so not much is happening. And still, we have over 9,000 events in the last 24 hours. So obviously, we're going to need to do something if we're going to find interesting network connections. And in this case, what we're going to be looking for are network connections that are regularly repeating, like a malware beacon calling out back to its home. So let's select just the network traffic now. I'm going to do where event ID is equal to 3, not 34, 3. There we go. And then we should see just network connections. All right, now if I expand one of these things, I will see some details here. Like I've got the process ID, I've got the process path. That might be interesting. The source IP address, and the destination IP address. And then this host name is a little bit misleading because it's not a DNS host name. It's actually a reverse DNS lookup of that IP. So the next thing that I want to do is I want to sort of summarize these somehow, right? Let's start out by just projecting the things that we want. So project will just take some of these columns. Let's project the computer because that would be important, the destination, IP address, that would be good. Oh, and let's do the process path too, because we want to see what process is responsible for each one of these connections, right? All right, and then how about the destination port? That makes sense too. Okay, so if we do that, now we'll see a nice summarization here where we can see when, oh, you know what? I didn't get the time created too. That would be nice if we can see what time that was. So let's do time generated, and now that will make a little bit more sense. All right, so already we're getting a feeling for something that we might want to investigate. You can see that run DLL is running very often. So this was at 1034 UTC, this is at 1035, 1036. These are very frequent connections, right? And they're all going out to the same IP address on port 80. So hopefully you're already seeing, if you were doing a real threat hunt, you would already want to start investigating these IP addresses. And here's another one. Here's another run DLL 32, and it's reaching out to this other IP address. But let's say that what we really want to do is, if we're in a real live environment, we're going to have a lot of these to go through. We still want to summarize these a little bit, right? So what I'd like to do now is I'm going to summarize, and let's do just the count first by, let's say, the computer, the process path, the destination IP, and destination port. And you can see IntelliSense helps out a whole lot. This is one of the things I like about Sentinel. You don't have to type everything. Okay, so this is interesting. Now we went from 9,000 down to just 92 unique items. And we can see that there's some of these that are recurring very frequently, right? So let's sort it by count. I think it was already kind of sorted that way, but we can see at the top of the list here, in the last 24 hours, there are 8,457 events, network events, going to this IP address from this run DLL, and then slightly less to this IP address. And then, of course, we see Teams pops up an awful lot, right? And then we've got another kind of suspicious looking thing here too, but not nearly as many connections. So what if we want to see the timing between those connections? The first thing that we'll want to do is we want to sort by, so that we get everything together that has to do with the same computer process and destination IP. So let's do sort by. The first thing we want to do is computer. The next thing is destination IP. And if you've ever done a multi-column sort in Excel, you kind of understand what I'm doing here. So I'm putting together all of the connections that are from each computer to the same IP, and then time generated. Let's see. And we'll do it in ascending order. Oh, I see. I need to get rid of this summarize now because I don't need that. I'm going to order this way. All right, now I've got things ordered. Now I want to do a special KQL function called serialize. Serialize tells it that I want to be able to do some computation between each field and the next one in serial order, if that makes sense. Now, we've already found something really interesting just with that simple query. So if the rest of this gets complex and you're like, wow, I don't even know what he's doing at this point, you've already got some useful skills in KQL, right? But let's take this a little bit further and let's do some statistical computations that Sentinel lets us do. So let's do the extend function. This is going to create a new column. So first, let's extend the next time, and that's going to be the time diff. Let's see, time, or maybe it's diff time. Date time diff, there we go. I'm glad that IntelliSense helped me there. We want to compute by seconds between the, or wait a minute, here, next time, I was getting a little bit ahead of myself. Next time is just next time generated, there we go. And now we'll do extend time diff. Extend, I'm going to call it delta time. The change in time is equal to date time diff, seconds between the next time and the time generated. Okay, so now we've computed seconds or second. There we go. Second is the right word. We've computed the time. Oh, I forgot a closing paren. There we go. We're computing the difference in time between each one of these connections and the next one, right? Okay, that sort of makes sense. Some of these are really weird numbers. They're negative numbers, and that's because we've got a difference between one destination IP and the next one. So we also want to extend the next computer is equal to next computer. There we go. And then let's do next destination IP is equal to next dest IP. Whoops, IP not port. There we go. Okay, so now we're going to have a record of what was the next computer and the next destination IP, and we can filter that so that we don't get the really strange results where we're computing a difference in time across things that don't make any sense, right? So I'm going to say another where clause, where next computer is equal to this computer, and next destination IP is equal to this destination IP. Okay, so if this works, then we should have the time delta. There we go, the delta time, and they're always positive numbers. These always make sense. Okay, we're getting somewhere, but still we've got these 9,000 records, right? So let's now do a summary. So I'm going to summarize. First, let's do make list. Make list of delta time. And I want to call that, how about just the delta time list? That makes sense to me. Let's call it delta time list. Whoops. List is equal to make list s time. And then by, and I need to tell it how I want to summarize this up. So I want to do it by, again, computer, process path, and destination IP. All right, so let's look at that and see what we've got. Now we've got, for each one of these processes that is talking to a destination IP, all of the list of delta times between their connections. Hopefully this is starting to look useful to you. So some of these
All
you
right,
can,
Randy.
yes.
It appears that the chat is of the opinion the pizza may be done.
Oh, thank you. I was hoping that you'd be watching that. All right, so let's take a look. Oh my goodness. As pizza chefs are fired, I'm sorry, this is an overdone pizza. Look at this. I'm still going to eat this pizza for sure, but this is very brown. I think it will be okay. And my wife is on the side laughing because this is pretty funny, but that is exactly the kind of thing that you can expect when you do a live demo of baking pizza, right? So what we're going to do now, as promised, is switch to the topic of how to create the pizza. And especially when you burn your pizza, you might want another one. So we'll get right to that. And then as we take questions, I'll see if there's more interest in the pizza topic or more interest in the threat hunting, and we'll get to the one that makes the most sense. Okay, can you see my screen, my video here?
Yep, it appears to be a measuring cup.
Excellent. All right, so I'm going to play the video and talk through how to make the pizza. But first, I want to introduce this topic by saying I've seen many, many pizza making videos that were about how to make the perfect pizza, right? And of course, that makes sense. You'd want to make the perfect pizza. But what I prefer, rather than chasing after the perfect pizza that is too difficult and you don't attempt, I'd much rather make the pizza that you have time for, that's simple enough that you actually do. Over the course of the last 20 years or so, I've calculated rough order of magnitude. My wife and I have probably made over 2,000 pizzas. And each time we do it, we try to make it a little bit simpler. And we've come to this, actually, we both make it a little bit differently from each other, but both are just fine. And we've come to the realization that pizza is very forgiving. It's really easy to make, and you can actually mess it up a lot and still get a very good result. So that's what I would like to share with you, the encouragement that you can do this. You can try it yourself, even if you've never baked any bread before. So start with some water. The rule of thumb is that you use about 3/4 of a cup of water per pizza. So I'm normally making 2 pizzas at a time to feed my family of 4 because we eat a lot of pizza. And so I use about 1.5 cups. That should be the hottest water that you can get out of the tap, not scalding, that you could still put your finger in and it's okay. You also use about 1 teaspoon of yeast per crust that you want to make. Now, if you have just a package of yeast and you're making 2 pizzas, just open the packet and throw it all in. It doesn't matter a whole lot. And I know real bakers will probably hate that I'm saying something like that, but as long as the yeast hasn't gone bad, it's fine. Now, I'll tell you one good pizza debugging tip or troubleshooting tip. If you find that your dough doesn't rise at all, it may have been that you put the yeast in too hot of water. The water is like boiling hot, you'll kill the yeast. Now, here is a pizza hack. I am putting in a teaspoon of brown sugar. My wife never puts in brown sugar. You don't taste it, but I found that it makes the crust brown up a little bit nicer, even if you don't have the oven parameters quite right. So I put in a teaspoon of brown sugar. Now, the trick is you don't really need to measure the flour. And that's a good thing, because if I'm trying to measure flour, adding it slowly a bit at a time, I always forget where I'm at. I always forget how many cups I've put in already, and the pizza gets ruined. So what I do is just add the flour a little bit at a time. And then once I've got enough flour in there that it's kind of looking like this, it's getting a little bit thick, then I add the salt. 1 teaspoon salt. Again, I try and keep things really simple, just a teaspoon for everything. The teaspoon of salt goes in at this time also to preserve the yeast. So if you put the salt in too soon, if you just mix the salt directly with the yeast, that can cause the yeast to die and then you won't get a good rise. But as long as you put in at least a little bit of flour, you can mix the salt in at that point and you have no trouble. Now, I just keep adding a little bit of flour, little bits at a time until the dough gets to the right consistency. That's the trick. Rather than measuring the flour out, you just add it a little bit at a time. Now, believe me, I have made mistakes with this many times and just I got lazy or I was in a hurry and I dumped in a whole bunch at once and it just made a mess. I also want to say you don't need a mixer to do this, but it makes it a whole lot easier. So once the dough is looking about like that, I want to show you another pizza hack. This is definitely a hack and not something a real baker would do. And I also want to be clear, I'm not going to microwave this dough, so don't be too aghast. What I'm doing here is microwaving some water to get it hot. And then I'm using the microwave as kind of a proofing chamber or rising chamber. That water will keep the inside of it humid and warm. And then I just put the dough into the microwave. But again, don't turn the microwave on. This would be disastrous, especially with the metal bowl. And just leave it in there for a while until it's risen and it looks like this. Now, if you have plenty of time, then you don't need to use the microwave at all. If you've got, usually 4 hours or so is about the time that I give for normal rising at just room temperature. My house is warm enough. I will usually come out from my home office at around lunchtime, eat my lunch, make some dough. It really doesn't take that long. And I'll just leave it out to rise. And by the time it's dinner time, the dough has risen on its own. But I often forget and I don't make the dough in time. And sometimes we've been at the point where it's like an hour and a half till dinner. We all want to have pizza and there's not enough time to let it rise. And that's when I use that microwave water and quick rising hack. And it works. So once the dough looks about like that, then you can take it out. And if you can sort of try to preserve some of the bubbles in the dough, that helps the dough to rise, but really however you do it is fine. This is my 9-year-old daughter helping me with the demo because at this point I couldn't both hold the camera and do the dough. So she's trying to get out about half of the dough, doing a marvelous job of it. I really enjoy baking with my family too. It's an awful lot of fun. And then this is the part where it starts getting kind of scary if you've never done this before and it seems like you're going to mess it up. It's going to work out. Just take a deep breath. It will be fine. Making pizza is a lot of fun. And The thing that can help you relax is to know that when you're making it at home, it doesn't matter if it's perfectly round. It doesn't matter if it's smooth. It doesn't matter if it looks perfect. It's going to taste just fine, unless you leave it in the oven too long and you burn it like I just did. But otherwise, it's going to be fine. So we have a clean counter that we've scrubbed down really well. And then we just add enough flour to this so that it's not too sticky and you can actually work it with your hands. You could use a rolling pin and roll it out, and that's not disastrous. But the only thing that will happen if you use the rolling pin is you'll kind of remove some of the air bubbles that have built up as that dough is rising really nicely. And so, I mean, your pizza will still taste fine. It'll just be a little bit flatter. It won't have those nice sort of risen bubbles in it. If you want to get the most bubbles, try to stretch it rather than roll it, if that makes sense. And this is the part that can get really scary if you try to get fancy with it. I have tried over and over and over again to throw the pizza dough into the air, twirl it around like some kind of expert. And you know what? Just about every time I've dropped the pizza dough and nothing good has ever come of it. So I don't recommend it unless you're just very talented at that. Just try to sort of stretch it out. Here's another pizza hack. All of the recipes that I've ever seen have said to put the pizza directly on a pizza stone. But I have a really hard time with that. Like I'm always messing up the pizza when I do that. So instead, I'll put it on a piece of parchment paper, which makes it a whole lot easier to get in and out of the oven. Now, here's the thing that I was kind of hoping would happen as we did this demo. The pizza dough tore. That is because I didn't let it run in the mixer and knead it long enough. The longer you knead it, the more elastic it becomes and the less that it'll tear. But what I wanted to show you is it's fine. Even if the pizza dough tears, you can just fix it. Just sort of pinch it back together again and it'll be just fine. Now, the most fun about making pizza at home is that everybody gets to put whatever toppings they want on it. When you put it in the oven, you want it to be the hottest oven that you can. And a pizza stone works great. Heat up the pizza stone in the oven ahead of time. But I have also made this on all kinds of metal pans, and it's also worked out just fine. This pizza, or this oven, I've heated up to 500 degrees Fahrenheit, which is 260 Celsius. And that's worked out really well. Real pizza ovens are like 900 degrees, and they're super hot. So you really can't get the oven too hot at home. This pizza is a special one. It's half dairy free and half full dairy cheese so that everybody can enjoy it, whether they can eat dairy or not. So I'd like to stop now and take questions and see if there are any questions about pizza or about the threat hunting queries. And then if we don't have any pizza questions, I'll get back to threat hunting and round it out with that.
Alrighty, yeah, your oven was perhaps a little hotter than people were anticipating by the look of it. Alrighty, so we have one person asking if you add a semolina, I guess, flour at the end to build the crust.
Oh, excellent. Yes, I've heard that the semolina flour will do a really good job, but I don't. I just keep it really simple. I've used all-purpose flour, sometimes bread flour. It comes out a little bit differently depending on what sort of flour you use, but any of those types of flours will work just fine.
All right, can the dough be over kneaded?
Oh, that's another really good question. So I actually have an excellent book called The Bread Baker's Apprentice, and the author deals with that very topic. And the author's opinion, which I trust quite a bit, is that you just cannot knead it too much. My own experience, and as a person who just tries things out, I have also experimentally just tried to let the pizza knead for a really long time, like 30 minutes in the mixer, or when I've done it by hand, just keep going until I can't knead it anymore. It's never been messed up. There's never been any problem with that. The only problem that I've ever had with pizza and kneading was not kneading it enough. So I'd say if you're not sure if you've done it enough, just keep going until you're tired of kneading, and then it'll be just fine.
All
Any other
right, switching back over to your other topic. We have a question as to whether you can detect beaconing with jitter. using KQL, or is that something that's too difficult?
Oh, excellent. I'm glad that that question was raised because that's where we're going to go with building this KQL query next. So if that's all right, it'll take a little while to answer that question. But the short answer is yes, we're going to use statistics. We're going to use a standard deviation and figure out, even if there is some jitter in the beacon check-in, we can find the ones that are most likely um, repeating. Now, I also want to point out that with the beacons that we're going to find here, we also just found them because they were the top of the list for computer process and destination IP, just the count of the number of connections. So it stood out that way as well, just because they're so frequent. But I'd like to show you this way to summarize and calculate the standard deviation because I think that's really interesting as well. All right, and I'm really glad my wife turned the oven off because I was getting very warm sitting with my back to a 500-degree oven. All right, so we've got the make list here. Let's do some other summations too. Let's do connection count. I'm just giving it a variable name here. It's equal to count, and we'll run that. Okay, now we've got number of connections. That's going to be useful. And then let's also do the standard deviation. So I'll just call this standard dev is equal to stdev and give it the delta time, right? That's what I called it. Delta time. There we go. Okay, so now what we've computed is not only the number of connections, but the standard deviation between the timing of those connections. And you can see that we're probably not going to find anything interesting, any sort of malware beaconing for anything other than under 10 connections, right? So let me filter that now and say where the connection count is greater than well, just for sake of argument, let's just do 5, just so that we see a few more results right off the bat. Okay, now we're seeing for a connection count with 10, there's a standard deviation of 9,166. And you can see that's because these delta times are all over the board. Like there was a connection, there's a pair of connections that the time between them was 6,241 seconds. There was another one that it was just 481 seconds. That doesn't seem very regular. So let's sort that, or let's sort by standard deviation, and let's do it ascending so that we have the lowest standard deviation at the top of the list. And if you're not familiar with this, this is just a measure of how regular the connections are. So if the standard deviation is very low, that means that there's not a whole lot of deviation between the values in the list. If the standard deviation is very high, there's a high degree of deviation between them, or a lot of variance. And you can see that just by sorting by standard deviation and putting the low numbers at the top, now we've got the most beacon-like connections, the most regularly repeating ones, right up at the top of the list. So this gives us a way that if we didn't even want to look at the rest of these, like let's say that we wanted to set this up as an alert that would run every so often and send us maybe a message on Teams, or start a new ticket or something like that. Let's just filter for the things that are very low on the standard deviation measurement. So this is where jitter comes in. Now, if you're not familiar with it, when you create a remote access tool like Cobalt Strike Beacon, and you're giving it configuration, you want to tell it how often to check in. And you'll also want to tell it how much jitter to put into the check-in times. And that's the amount of random variation between check-in times. And the reason for jitter, if you're a red team operator, is to avoid a blue team doing analysis just like we're doing here. You want to be able to fly under their radar. So instead of having a check-in like every 10 seconds, 10, 10, 10, 11, 10, 9, 11, that type of check-in, which is so easy to spot. You want to do something that is, maybe 5 seconds here and then 15 seconds later on. Try to get the standard deviation up a little bit and maybe hide in the noise. That's the point. Now, the only way that you can really hide in the noise using this sort of regular repeating check-in is to have a very long polling interval, maybe 15 minutes between check-ins, and then have a high degree of jitter so that one time you're checking in, 1 minute later, the next time it might be 15 minutes, and create a lot of variance in there. Now, the reason that I think a lot of red team operators and definitely professional threat actors don't do that. And let me just say, I've studied an awful lot of malware beacons, and I almost never see that kind of jitter. The reason they don't want to do that, in my opinion, is because it's really annoying as a red team operator to work with a beacon that you don't know when it's going to check in again. That means you're sitting on the other end of the keyboard typing some command, and you don't know if it's going to run in 1 minute or 15 minutes or maybe an hour later. That makes your workday go really, really slowly, and you start to wonder if your beacon is even working at all, right? So let's first filter. Let's do where the standard deviation is, let's say, less than, and here's where we as the threat hunter, are going to pick a number that makes sense to us. So just looking at these numbers, I'm going to say, how about standard deviation is less than 200? I think that's going to highlight just the connections that we're interested in. That seems to be doing a pretty good job. Now we can see these standard deviations are really low, but I've seen an actual malware beacon with, I think it had 10-minute polling intervals and a really high degree of jitter. It ended up being about an 87 on the standard deviation scale. So this should still get us the values that we want. Now, the next thing that we want to do is maybe expand our time that we're searching and see if we still get reasonable results over a longer period of time. Now you can see we've got a few more things that are popping up on our list. This is over the last 7 days in this lab environment. And we can see, okay, run DLL, this vloader 2, that looks suspicious too. These other run DLLs, these are all definitely suspicious. Not so sure about this one though. This is sort of weird. The destination IP is IPv6, and it looks like there's a whole bunch of 0. So these were a whole bunch of connections that happened at the same time. Now, I don't really want to see that result. So what I'm going to do is tune this query a little bit more. And let's say for delta time, I don't really care about delta time 0. So let's put another where clause here and say the delta time is greater than 0, or I could even expand it and say greater than 1. I don't think I've ever seen a malware beacon that its check-in time was 1 second. That would be incredibly noisy. We'll probably catch it another way just by most amount of traffic. So I just did the delta time is greater than 1, and now you can see I filtered out some of those things that I didn't care about so much on the list. I'm pretty happy with this right now. Like if I had over the last week, my Sentinel sent me an automated alert to say, hey, you might have a beacon you should check out for each one of these. Those would be good results that I could actually do something with. So let's see, we've got a little bit of time left. I've got some more things that I could do, adding in some DNS data here, or maybe looking up some of these IP addresses in threat feeds. But I'd like to go back and see if there are any questions that I can take before we run out of time.
The one that showed up earlier is admittedly somewhat controversial, so I'll go ahead and elide the controversial part. But what are your favorite toppings for pizza?
Oh my goodness. So I am an adventurous pizza hacker, and I like putting weird things on pizza. So my favorite thing to do is actually ask other people what they like on their pizza and then try that. Somebody from Germany told me not long ago that tuna right out of a can was a good topping. And I have to admit, I was not so keen to try that because tuna's okay on a sandwich, but I didn't think it was going to be good on pizza. I tried it, It was pretty good. Not one of my favorites, but it was definitely worth trying. I enjoyed that. Something else I've done on pizza that has come out really well. I'm in the Pacific Northwest, and smoked salmon is huge here. So I did some cream cheese and some fresh mozzarella, and then put the smoked salmon on top. And I actually put the smoked salmon on after it came out of the oven so that it didn't dry it out too much, and it was still just that perfect sort of moist salmon with a good smoky flavor. I thought that was really good. I also like fresh toppings. After the pizza comes out of the oven, I like to put fresh basil and some, what are some of the other fresh things that we put on? Oh, fresh tomatoes. That's really good. And I like them when they're not all baked and dried. But really, pizza toppings are personal. And I think whatever you like on your pizza is the right thing to put on your pizza. And unless you just like to be adventurous like me, you don't really even need to worry about what other people like on theirs.
Fantastic. I like the way that you handled that particular question there. That's something that can get a little fraught with some people.
Oh, for sure. Any other questions?
I don't see any. Everyone is now talking about how they really want a pizza now, despite diets and other such impediments.
Oh, good.
So I think that you've gone and nerd sniped the entire channel at this point.
Excellent. All right. Well, I've got a little bit more. I wanted to add on to this query. And just because we're running short on time, I want to sort of show you what other data I've added into this. So this is pretty much the same query that we built before. But I've added on DNS data because I wanted to see, has there been a DNS query that resulted in an answer of one of these IP addresses before? So what I've done is a KQL join. And if you've ever done SQL database queries, you should be familiar with joins. They're so valuable, and it works in KQL as well. So I've told it that the kind of join I want is left outer. What that means is I want all of the results from the left table. The left table is this, right? It's this result that we're looking at right now. In other words, even if there is no DNS query that matches this IP address, I still want to see this result. I just want to see that there was no DNS query because I don't want, pardon me, adding in extra data to cause me to miss some of these really important results. So then I've joined it to another custom data source that I've got. In this environment, I've got both Suricata and Zeek. Both of those will read DNS queries on the wire. And then I've used another really, really handy KQL function here called parse JSON. Parse JSON is one of the parsing functions along with parse CSV or parse XML that will take a field that's in your results and make it so that you can query inside of that. So I'm going to skip ahead where I figured out that in Suricata, the DNS is the question and or the answer is put in a JSON format, and I just care about the first one. I want to extend the answer R data, which is the resource data coming back into this new field called R data. Then I want to summarize by the resource record name, that was the query, and the R data. So in other words, I'll just take this query out actually, and you can see what this results in all by itself. I think that will be really instructive and helpful so that you understand where I'm going with this query. Here we go. All right, so let's just run this for the last 4 hours so we don't get bombarded with a lot of results. So what this is saying is that these are the queries and, sorry, these are the queries on the right and on the left. These are the responses. And so I can see already there's one of my IP addresses that the Cobalt Strike beacon is calling out to. And the DNS query that was made for that is wellernaft.top. And I think we're just about done with time. So I will
Yeah,
close it there. And thank you so much. I'm going to be around in Slack chat, so I'll be happy to keep chatting with you and answering questions.
fantastic. Thanks for bringing your double live demo to PancakesCon, Randy. We're very glad to have had you here.